So a complex number had two parts, a real part and an imaginary part, and we did addition, multiplication, subtraction, the conjugate, the length. So what we were going to start with today is what's called polar form. Okay, so polar form. So up here, this is called standard form. And polar form is r cos theta plus I sine theta. So r is the modulus of z, which we said last time was a squared plus b squared. Theta is between 0 and 2 pi. And, okay, so we're going to find it. So basically here, A from our standard form is equal to r cos theta, and B is equal to r sine theta. So what you need to do, and we'll jump right into an example. Basically, you need to find the value of theta to convert a number that is in standard form, say 1 plus I, into polar form. Okay, so that would be the question. So here's it in standard form. Write 1 plus I in polar form. So I'll show you how to do that. So we do have a calculator, so you can use your calculator for values that don't work nice, but you really do need to know pi over 3, pi over 6, pi over, but just the standard ones. So let's just write them down. Okay, so we need to your trig values. So our basic trig values for sine, cos, and I'm going to put tan here because I'm going to show you how I do it after, which involves tan. So 0, pi over 2, pi, 3 pi over 2, 2 pi, so these are not in numerical order, but okay, so if you use a unit circle or whatever, your triangles, however it is that you know the values, maybe you draw sine and cos to get the values. I just have this table memorized, so this is how I do it. Start at sine of 0 and write 0, 1, 0, 1. And then the opposite for cos. The second one is negative. So that gives those values. Cos of pi over 3 is 1/2. Sine, that's the opposite. These are root 3 over 2. And these are both 1/2. 1 over root 2, sorry. Or root 2 over 2. Whichever, if you did the triangle. Okay. So how would we get tan from this? Well, tan is sine over cos. That's just an identity. So I've got these as fractions, sine on top and then cos, so 0 over 1 is 0. 1 divided by 0 is undefined, 0 over 1. 1 divided by 0, 0 over 1. 1 over root 2, 1 over 2 divided by root 2 over 2, the 2's cancel, so this would be 1 over root 3. These are the same two numbers, so 1 and root 3 over 2 divided by 1 over 2, the 2's cancel, and we would have root 3 over 1, which is just root 3. Okay, so you're expected to know those values, and any other values, like say pi over 8 or pi over 12, you would just use your calculator in radians. okay, to get those, and we'll do an example of both so you can see what the difference would be. Okay, so now that we know all this, we're just going to convert the numbers. So we'll start with 1 plus I, because that's just a normal. So in the book, I noticed that this is how they do it. So if we wanted to convert 1 plus I, so A here is 1 and B is also 1. Right? So first you would find R. R is square root of 1 squared plus 1 squared, so root 2. And then you go back and use A equals R cos theta to find theta. So A is 1 and R is root 2. So we would have 1 over root 2 equals cos. And sine, B equals R sine theta. So B over R equals sine. 1 over root 2 again. All right. And so, because I gave us an easy one to start with, this is not a problem at all. This is saying that we want a value of cos or a value of theta, where cos is 1 over root 2 and sine is 1 over root 2. So this is easy because it's right here. We don't need the calculator or anything like that. It's pi over 4. What's that?
You should memorize that table?
Yes. Well, you might know the unit circle or the special triangles. You might have a different way that you had originally learned trig.
Yeah.
I learned it in a table, so I can write the table down really quick on any test I would need it. But if you did a unit circle or something like that, I'm going to show you my way if you did just know these values. I'll show you how to do it that way. But basically this one's easy because 1 over root 2, 1 over root 2 is pi over 4. So you would say theta is pi over 4. So we have R, and we have theta, and then we would just write the polar form. So we would write that in as Z equals, so it's R cos theta plus I sine theta. So root 2 cos pi over 4 plus I sine pi over 4. And that's it. You would stop. You don't work these out, or you'd go back to 1. Right? That would be a check if you actually worked them out. You could put them in your calculator and see if you get 1 plus 1I. Right? But the polar form is actually leaving it with the cos and sines like that. Okay, so let's say convert to polar form as the instructions, and we'll do a couple different ones. So, for example, Z equals, let's do 2 minus 2I. Okay, so we'll put a negative sign in there. Okay, so I'm going to show you 2 ways to do it, and I'm going to show you the book way in case you're reading the book. But then I'm just going to show you my way, and I'm going to just keep doing it my own way, okay, which I think is easier, and that's why it's my way. But you guys might like the cos and sine way better that we just did. So first you would find R. So, no. I'm just going to do one more time their way. I just don't want you to be confused if you look in the book and they didn't do what I do, so I want to show you one more time how they do it. So method 1 is R, you find your R. So what's A and B here? A is 2 and B is negative 2. You don't take your I, remember, just the constant. So this would be 2 squared plus a negative 2 squared. 4 plus 4 is root 8. So this is 2 root 2. And then they say A is R cos theta. So A is 2 over 2 root 2. over root 2, pi over 4 again, and sine, so b over r. b is negative 2. Okay, so because we have some values memorized, these are the same values. So it's pi over 4, but what's the problem? This one's negative. So we actually need not pi over 4. That's called the reference angle is pi over 4. If you remember about trig, is pi over 4. But the cast rule says, so we want pi over 4, but we want it in the quadrant where cos is positive, because this value is positive, and sine is negative. So where would that be? The C cos, so yeah, A stands for all are positive. So this one would not be that, because we want sine to be negative. The C is cos is positive, everything else is negative. So cos is positive and sine is negative would be right here. So if we want that pi over 4 as a reference angle in that quadrant, here it is, the reference angle is always between your x-axis and your terminal arm, wherever you are drawing it. So we put the pi over 4 in here. Now remember that I said at the very beginning that theta is between 0 and 2 pi. So we don't go negative, we go around in the positive direction. And so we say, what is this angle? So do you remember how to do this? So if we're dividing this up, just if we have pi over 4, that means cut pi, this is pi right here, cut pi into 4 pieces, 1, 2, 3, 4. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And then you would cut this one into 4 pieces, so 5, 6, 7, 8. We want this one. So if you're thinking this, we go around through 7 pi, so 7 pieces. So our angle is 7 pi over 4. Okay, now my way is mostly doing that same thing, except I don't ever write sine and cos. I just go to tan. Okay? So tan, if you have it in the right quadrant, then all you need to actually know are the values of tan instead of sine and cos. It's less writing. And I'll show you how to know what quadrant it's in without looking at the plus and minus sign at all. Okay, so I don't look at the cast rule and say, okay, cos is positive, sine is negative, or sine is, okay, I don't look at both are negative, we go here, I don't look at that at all. This is my method. Okay, well, let's finish writing this. Z equals R 2 root 2 cos 7 pi over 4 plus I sine 7 pi over 4. Okay, so that's the actual answer. That's a Z right here. Okay, so method 2 is this. You're finding the value that makes cos 1 over root 2 and sine negative 1 over root 2, which is this value. So you're finding where they both 1 over root 2, which is pi over 4 as a reference angle. So that'll give you the 1 over root 2. The quadrant that it lands in tells you the sign. So if you evaluated this, this gives me 1 over root 2, and this gives me negative 1 over root 2. Multiply by this, and we get back to our original number. All right, multiply that in, we get 2. Multiply it in here, we get minus 2. All right, so it goes back to where you started. Okay, so method 2 is this. You still find R. So 2 squared plus a minus 2 squared. Which is root 8 or 2 root 2. And then we do tan theta is, what do you think? It's sine over cos is tan. And so what is the sign, the A or the B? the B. So B over A. Okay? And in fact, I just ignore any plus or minus sign. Because I'm going to deal with that separate. So we just divide A and B and ignore whether they're positive or negative, doesn't matter. Okay? So if we're ignoring whether they're positive or negative, we just put 2 over 2, which is 1. So my question is, where does tan equal 1? So, if you know your value is just of tan, or you can put that in your calculator and figure out what it is, but it's kind of hard to convert to pi over something. But here's tan. So it's 1 at pi over 4, so we will get the same reference angle. We're still dealing with the same number. So we get pi over 4. Now, how do we figure out what quadrant it's in without doing the castrol? It's easy. Remember I told you how to plot this as a point on a graph? 2 minus 2? Plot the point, and that tells us where it lands. So if we plot that point, we go over 2 and down 2. We're right here. So there's the number. Put your pi over 4, which we just found by our tan here, and then figure this out. So you still have to do that part. And then you can write your number with r is 2 root 2 and theta as 7 pi over 4. Okay, so we'll do a couple more. Let's say root 3 plus I. So what's A and B? A is root 3 and B is 1. Okay? Actually, let's make it a negative to make it harder. We don't just land in the first quadrant. So A is negative root 3 and B is 1. Okay? So we need to find R. Root 3 squared is 3. So R is 2. And we need to find tan of B over A, ignoring the signs. Okay, it doesn't matter if you put the sign in there or not. You say, where does tan equal 1 over root 3? So tan is 1 over root 3 at pi over 6. Pi over 6? Yeah. So our reference angle is pi over 6. That's not our answer. We need to know where it is. So there's 3 steps. 1, 2, and 3 is to draw the angle. So to draw it, we're going to plot the point, negative root 3, 1. So where would that land? So negative and up. So negative root 3 and up, we land up here. And our reference angle is pi over 6. That always goes between the x-axis and the line you just drew. And this is always our start. So we say, how many pieces is this? All the way back to this line is pi, which would be 6 pieces. So if we have 1 less, it would be 5. So 6 is all the way to the end. 12 is all the way to this end, right? It's 2 pi all the way around. So if you take out a 6, then you have 5 left. So 5 pieces. So our angle theta is 5 pi over 6. And then you write your polar form. So step 4 is to write it. So R is 2 cos 5 pi over 6 plus I sine 5 pi over 6. You can check these in your calculator without even looking at your values, because if I have this in radians, I can do 2 times cos of 5 pi over 6, and I get negative 1.73. And then remember that 2 is really in front of each. So then for your other number, you would do 2 times sine of 5 pi over 6. 5 times pi divided by 6. And I get 1. And is negative 1.73 root 3? Probably, because we did it right. Root 3, 1.73, right? So it gives you your right answer. So you can always check by just putting it in the calculator and making sure you get back to where you started. But the only thing is, remember, that's a check. Your actual answer is this. What I see sometimes people do, they check it and then they write their answer as the original question. Right, they go back to the start. Right, because they feel like they just solved something, so then they circle this. I'm like, that's not quite right, because your answer was there, not this. Do you know what I mean? I see people do it all the time, so I just want to know, don't, when you are asked for polar form, make sure it's in polar form with the sines and the coses when you stop. I think because people see this and they feel like they should evaluate it, because it doesn't have an X or something in it. They just feel like that it has an answer, but this is the answer, okay? So be careful about it. All right, example 3. Say we had Z is 3I, just 3I. So what's A here? 0. And B is 3. So step 1 was to find R, 0 squared plus 3 squared. So 3. 2 is to do tan of B over A. So B is 3 divided by A. What do you think? Undefined. And remember, tan was either 0 or undefined. Now, when you do this, we don't even need to do this tan bit for this one. We don't need to draw the angle, or all we need to do is draw the angle. Because 3, if we draw the angle, we will know the angle, because if you draw this point, 0, 3, where is that? 0, so we don't go to the left or right, and up 3. So that is the angle, right there, we landed on it. We didn't have to figure it out. What is that angle? 90 degrees is pi over 2. Right, this one is pi, 3 pi over 2. And this one is 0, because we start at 0. And at the very beginning I said, you may not have noticed, but I said it's between 0 and 2 pi, and I didn't put an equals on the 2 pi. So if you land on that first one, you actually write a 0 in as your angle. So we don't put the 2 pi, we put the 0 if you land on that arm. So if we land right here, our angle, theta, is pi over 2. So our polar form, r cos pi over 2 plus I sine pi over 2. Cos of pi over 2 is 0, sine of pi over 2 is 1, so we'll have 3 times I, 3I. But don't write that, because that's a check. So that being said, what if we had like a question that looked like this? A is minus 5, and B is 0. So if we draw that, where does it land? So minus 5, 0 is here. What's that angle? Pi. And you don't need to do any tan or cos or sine or anything. It's just there. So the angle is pi, and we need r. It's a squared plus b squared, which you don't need to do either, if you notice the pattern here. Because it's the length. This gives us our length. How far is this from the center? 5? Thank you. Right? If it lands on one of these, that absolute value is the absolute value. So 5, so our answer is 5 cos pi plus I sine pi. Okay. So that's polar form. We'll do a couple more because we're going to do questions with polar form. Okay, so how to multiply numbers in polar form. So if we have Z is equal to R cos alpha plus I sine alpha, and a second complex number, instead of R, let's put T, cos beta plus I sine beta. So two different complex numbers. And if you want to multiply Z times W, you multiply R times T, so that part's easy, and you add the angles. So it's cos of alpha plus beta plus I sine alpha plus beta. So that's multiplication. And then division, you subtract. So if we wanted Z divided by W, we would do R divided by T, R divided by T, and then subtract. Now make sure that you actually subtract top minus bottom, because it will give you a different angle if you go the opposite way. So it would be cos of theta, or alpha minus beta, plus I sine alpha minus beta. Okay, subtract the angles. And then you would work them out. I'm going to write down the other two laws, and then we'll do an example. So the next would be the conjugate. And the conjugate is just the same. So say we wanted Z, we would say R cos. So if Z was R cos alpha plus sine alpha, then the conjugate with a bar on top is just minus. Okay, just the same, change the, oops, forgot the I. Don't forget the I. And then powers. So if we wanted to find Z to the power n, then that would be R to the power n cos n times theta, or whatever your angle is, plus I sine n times theta. Okay, so we'll just do an example with all these things. So the power especially is useful here. The other ones weren't so bad in standard form doing them. But powers, if I wanted like 1 plus 3i all to the power 20, that would be multiplying it, foiling it out, 20 brackets. You wouldn't want to do that, but if you converted to polar form and then just did one calculation, that would give you the whole answer. Okay, so now on the test, I didn't make the final up yet, but it would be similar. On the test, I said in polar form and in standard form, so you didn't get to choose. In real life, I guess you would choose what form you wanted to do it in, right? And people wouldn't pick trig. They probably would just multiply out 20 brackets instead of doing trig. People avoid trig at all costs sometimes, yeah, but you shouldn't. Okay, so let's do an example. So we'll just give two different complex numbers that are easy to convert to polar form. So let's say minus 2 minus 2 root 3I, and, oh, not Z, say W is 1 minus, or let's do 4 minus 4I. Okay, so here's two complex numbers. So what we did last class was we multiplied them by FOILing. We divided them by using the conjugate. We didn't do a power because that would be too long. So we're going to first convert them to polar form. So Z. So this is the point minus 2 root 3. So if you were plotting that on the graph, minus and a minus, it would be down here. Right? So we need to find this angle. So we do that. So we need R is A squared plus B squared. 4 plus 4 times 3, 4 plus 12. Okay. And tan theta is B over A, ignoring the signs because the sign is going to be taken care of when we draw it. So just root 3. So where does tan equal root 3? So those are our memorized values. It's equal to root 3 at pi over 3. So this reference angle right in here is pi over 3. So what's this? So this would be 3 pi over 3 all the way here, and then we want one more piece. Right, so 4 pi over 3. It's either going to be 1 subtracted or added to this, or 1 subtracted or added, or I guess from here. All right, so our first one, Z, is 4, that was our R, cos 4 pi over 3 plus I sine 4 pi over 3. And then W. Four minus 4I. So if we draw that as a point, 4 minus 4. So positive 4 minus 4 is down here. We need to find that reference angle. We need R. Oops. (32) 16 times 2 over 4 root 2. And tan B over A, so 4 over 4, which is 1. Ignoring the sign, because the sign, again, is just in where we draw it. Doesn't matter if you put it here. And I say ignore it because when people write -1 and then you look at your chart, you say, well, tan doesn't equal -1 anywhere. Right? But the negative doesn't matter, it's the 1 that matters. You're ignoring the sign so that you can get that actual value that you want. Right? Tan doesn't have any negative values in here, the ones that we know. Right? So you're just looking to see if it's one of these 3 numbers, basically. All of these other ones will land right on one of the axes. And it's just these 3 you need to know. Right? You don't need to know any of this, really. Just these 3 values, which one is with which angle. Because these ones will land right on one of the axes. And you can just see which one it is. Okay, So tan of 1 is at pi over 4. So if this is a pi over 4, we don't want to go minus, we want to go around from the start to here. So this one would be 4 pi over 4, and this is 2 pi, so it would be 8 pi over 4. Right, 8 divided by 4 is 2. So this is 1 less than 8, so 7 pi over 4. So W is 4 root 2 cos 7 pi over 4 plus I sine 7 pi over 4. Okay? So, we've got our two numbers in polar form. If I'd given them to you in polar form, that would even be easier, but I won't do that. So there they are in polar form. I'm going to write them down at the top of the next page, and then we're going to multiply them, divide them. We don't usually add in polar form. You would do that in standard form, although you could. You just figure out your two values and add them together. There's no special formula for it. Okay, so we'll just write these down. So if we wanted to multiply them, so our rule to multiply was to multiply the two and then to add the angles. Oops, yeah, so that's what we said. So here Z times W would be 4 times 4 root 2 cos of 4 pi over 3 plus 7 pi over 4 plus I sine 4 pi over 3 plus 7 pi over 4. So just regular fractions, common denominator. I wouldn't write it all out to do that. I would go off to the side and just calculate this as a number and then write it over again. So if we wanted them to be over 12, so multiply this by 4, so 16 pi over 12, and multiply this one by 3, 21 pi over 12, so 16 plus 21, 37 pi over 12. So Z times W is 16 root 2 cos of 37 pi over 12 plus I sine 37 pi over 12. Now, pi over 12 is not a value, we know. But if you were asked for it just in polar form, you just leave your answer like that. You had nothing to do. If you wanted the answer in standard form, you would just use your calculator in radians. Right, so say, for example, I asked you to plot the point. You would then need to actually find the values in the calculator. So I would do 16 times root 2 times cos of 37 times pi divided by 12 in a bracket equals. So my first number will be minus 21.86. Now with this calculator I can just go back and change the cos to a sine without changing anything else, and I get minus 0.86 I. So here it would be in standard form. And then you could plot your point. Okay, does that make sense? So Z divided by W. So the rule was just to divide and then to subtract. Oops, I forgot the sign. Okay, so Z first. It goes on top. 4 over 4 root 2 cos of 4 pi over 3 minus 7 pi over 4. So 1 over root 2 cos 16 minus 21. 16 minus 21 is 5. Make sure you subtract them in the right order, because that will matter in your answer, switching it to polar or to standard form. Right? So when you add, subtract, it probably goes out of the 2 pi range. This is bigger than 2 pi. But remember, angles repeat, so it's okay. It lands on just when you're first converting to polar form. You could find to be technically correct, you would actually draw this and then find what the equivalent would be between 0 and 2 pi, but we don't need to bother with that in here. But outside of this, if you were using these other times, you would find where is negative 5 pi over 12 is like here, and so then you'd say, okay, what is this between 0 and 2 pi the same as a pi over 12? Right. But we don't need to do that. You just plug this into your calculator. Whoops. So, and again, I would do 1 divided by root 2 times cos, put a bracket, negative 5 times pi divided by 12, and my bracket. So my A will be 0.18, and then I can go back on my calculator and change the cos without retyping it all. Minus 0.68i. Okay, so we're dividing the numbers. Now, if you did this in standard form with the same thing, you're getting fractions and you convert them to decimal, you'll get the same answer. Okay. All right, what about z to the 10th power? So the rule for this was r to the 10 cos 10 times whatever your theta is plus I sine 10 theta. So our z was 4 to the 10 cos of 10 times 4 pi over 3 plus I sine the same thing. So 40 pi over 3. And then you would evaluate that. 4 to the 10 I would probably just leave as 4 to the 10, but let's see. You could do it. It's big. Right? I'd probably just leave it as 4 to the 10, but we could do that. 4 to the 10 times, no, we want to do this over again. 4 to the 10 times cos of 40 pi divided by 3, negative 288, and change the cos to a sine, negative 908093.45i. There it is. Much, much faster. Even if you had to convert them both to polar form first, it's much faster to do powers this way rather than writing out that number, multiplying the first 2 brackets, then those with the next one, and so on until you get 10 brackets long. Right, if we were to do z to the 10 in standard form, what was our z in standard form? Z was minus 2 root 3i to the 10. So you would write that out. Ten times. So in math you do this. So, and how would you actually do that? You would multiply the first two, get that answer. Then you would take that new number, multiply it by the next one, get that answer, multiply it by the, right? So it's way too long. Okay, so we're going to stop this video and we'll start a new one with the next topic.